Welcome to section 2.1. We're going to be talking about polynomials, mostly focusing on quadratics. Now, a polynomial in standard form, don't be afraid by the notation. All it's saying is that we're going from the largest exponent to the smallest exponent, and that's all it says, the x to the n. It's just going down in degree. When we're talking about degree, we're talking about the exponent of the largest of the variable, the largest exponent of the variable. So now, if we have no variable, if we just have a constant, the degree is 0, and we call that a constant polynomial. When the degree is 1, when we have x to the first power, we call that a linear polynomial. When the degree is 2, when we have something like x squared, we call that a quadratic. And that's what we're going to be focusing on today. When we have a degree of 3, that's cubic. When we have degree of 4, we call that quartic. Think about 4 quarters in a dollar, 4 quarters in a game. And degree n, that's the generic term for a polynomial. So we'll be talking about those as we go through the rest of the year, the different types of polynomials we have. Like I said, today we're going to be talking about quadratics, when we have x squared. Now, just some refreshers. Remember, the shape is U-shaped. And we call that a parabola. That's the shape of a quadratic. That's when the degree is 2. And the axis of symmetry is that vertical line through the x-axis of the vertex, or through the x-coordinate of the vertex, excuse me. So you can go and look through that. You can see when the leading coefficient is positive, leading coefficient is negative. That's what we're going to be talking about on the next page. So when the leading coefficient is positive, it opens up. When the leading coefficient is negative, it opens down. When it opens up, we have a minimum at the vertex, and when it opens down, we have a maximum at the vertex. So if you look at the graphs of x squared and 1/3 x squared, on your calculator, you notice that for the 1/3 x squared, it opens wider. It is vertically compressed. When you look at the graphs of x squared and 2x squared, the one with the 2, it's narrower. It's vertically stretched. So what A does, A affects the width. It's going to cause that vertical stretch or vertical compression. And we can summarize that down here at the bottom. You can see here is a quadratic function. We call this standard form. Also, it's known as vertex form. This is the form we're going to see most of our quadratics in. It's the easiest form for us to work with because we know where the vertex is and we know the different transformations that occur, whether it's a shrink, a compression, reflection, shifting left, right, up, down, and so forth. So the vertex is at H and K. I don't know why that says that. H and K. The vertical line, x equals h, is the axis of symmetry. Now, if a is greater than 0, if it's positive, it opens up. If a is less than 0, it opens down. Now, if the absolute value, I don't care if it's a positive or negative, but if we have a number greater than 1, it's going to be a vertical stretch. If the absolute value of a is between 0 and 1, whether it's positive or negative, once again, it's going to cause that vertical shrink, that compression. And then you can see the shifting left and right with the values of h and k. And then just some information about the axis of symmetry, where the vertex is located. The x-coordinate of the vertex is always at negative b over 2a. And what you would do is you just substitute to find the value of y for the vertex. So that's when it's in that general form, ax squared plus bx plus c. So instead of working with this in the general form, we're going to switch it into that standard form. So we're going to use our completing the square that we talked about previously. I'm going to divide each term by 2. So I have f of x over 2 equals x squared plus 4x plus 7/2. I'm going to subtract 7/2 from both sides. F of x over 2 minus 7/2, leave some space, equals x squared plus 4x. We're leaving that space because we're going to be adding the b over 2 squared. So we're going to be adding 4 over 2 squared to both sides. So we have f of x over 2 minus 7/2 plus 4 divided by 2 is 2 squared, which is 4, equals x squared plus 4x plus 4. So I don't really care about the fraction, so I have f of x over 2 minus 7 over 2 plus 4 equals, and when we factor, we get x plus 2 squared. Now, we can't have all of that there, and I want to get rid of the fraction first. So I'm going to multiply each term, everything by 2. That's 4 terms. So I get f of x minus 7 plus 8 equals x plus 2 squared. So that's f of x plus 1 equals x plus 2 squared. Subtract 1 from both sides, f of x equals x plus 2 squared minus 1. Oops, sorry, I lost my 2 early on. That's 2 times the quantity of x plus 2 squared. So f of x equals 2 times the quantity of x plus 2 squared minus 1. So now, right away, I know where my vertex is. My vertex is at negative 2, negative 1. The axis of symmetry is at x equals negative 2. And then we'll go through and find our intercepts and so forth. So to graph it, I'm going to use my parent functions and my transformations. So my parent function is right here. Those are my anchor points. And now what we're going to do is we're going to multiply all the values by 2, the y coordinates, times 2, times 2. So we're at 2, 8, negative 2, 8, negative 1, 2. And then we're going to shift everything to the left 2 and down 1. Left 2, down 1, left 2, down 1, left 2, down 1, left 2, down 1. And there is our graph of this function. Now, I can see where my y-intercept, but I don't know where my x-intercept is. So what we're going to need to do is we're going to need to find that x-intercept or the x-intercepts algebraically. Now, to do that, I'm going to use I'm going to use this function I just wrote. So for the x-intercepts, y is 0. So 0 equals 2 times the quantity of x plus 2 squared minus 1. Add 1 to both sides. 1 equals 2 times the quantity of x plus 2 squared. Divide both sides by 2. 1/2 equals the quantity of x plus 2 squared. Now we take the square root of both sides. Plus or minus. Now the square root of 1/2 is 1/4. So we have plus or minus 1/4 equals x plus 2. Subtract 2 from both sides. So x equals negative 2 plus or minus 1/4. Now I want to get a better answer than that. So x equals negative 2 plus 1/4, and x equals negative 2 minus 1/4. Now we need a common denominator of 4. So we have negative 8/4 plus 1/4. That would give me x equals negative 7/4. Then we have negative 8 minus 1, negative 8/4 minus 1/4, which is negative 9/4. So my x-intercepts are at negative 7/4, 0, and negative 9/4, comma, 0. Those are my two x-intercepts, and to find my y-intercept, once again, y equals 2 times 0 plus 2 squared minus 1. 0 plus 2 squared is 2 squared, which is 4, times 2 is 8, minus 1, so y equals 7. So it's at 0, 7 for the y-intercept. And we could see that from the graph, but don't forget you can always find them algebraically. Let's go to another one. Number 5, once again, we're going to start by dividing everything by 3. So I have f of x over 3 equals x squared minus 8x plus 50/3. Don't worry about the fractions here. So we're going to start by subtracting 50/3 from both sides. So we have f of x over 3 minus 50/3, leave it blank, equals x squared minus 8x. In that space, we're going to be adding negative 8 over 2 squared. So f of x over 3 minus 50/3. And now negative 8 divided by 2 is negative 4 squared. That's going to be plus 16. And that equals x squared minus 8x plus 16. So once again, don't worry about the fractions. F of x over 3 minus 50/3 plus 16 equals x minus 4 squared. So now to get rid of the fractions, we're going to multiply each term by 3. So I have f of x minus 50 plus 48 equals 3 times the quantity of x minus 4 squared. F of x minus 2 equals 3 times the quantity of x minus 4 squared. Add 2 to both sides. F of x equals 3 times the quantity of x minus 4 squared plus 2. There's our function in that vertex form, that standard form. So the vertex, we know right away, is at 4, 2. The axis of symmetry, x equals 4. So now we can start by graphing the parent function as we have in the past. So there's my anchor points. I have a vertical stretch of 3. I'm going to multiply each of the y coordinates by 3. And you can see it grows really fast when we multiply that by 3. And now we're going to shift each point to the right 4 and up 2. And that other point's going to be way off the graph. So here's what our graph is going to look like. Now, there's our graph. You can see that we're opening up above the x-axis. We're not going to have any x-intercepts. So for our x-intercepts, there are none. Now for our y-intercept, I don't see where that's intersecting, but it will intersect. So what we could do, y equals 3 times 0 minus 4 squared plus 2. So it's 3 times negative 4 squared is 16. So it's 3 times 16 plus 2. So y equals 48 plus 2, which is 50. So the y-intercept is there at 0, 50. And you can see that's way off the graph. And there is that graph. Let's go to the next page, please. Let's do one more graph. So now we have a negative leading coefficient. So once again, we have to divide everything by -1. So f of x, I'm just going to make that a negative f of x, leaves equals x squared minus 6x plus 8. So I'm going to subtract 8 from both sides. Negative f of x minus 8, leave some space, equals x squared minus 6x. And then we're going to be adding the negative 6 over 2 squared to both sides. So negative f of x minus 8, negative 6 divided by 2 is negative 3, squared is going to be a positive 9, equals x squared minus 6x plus 9. So we have negative f of x plus 1 equals. And when we factor, we get x minus 3 squared. Now, I don't want a negative f of x. I want a positive f of x. I want to multiply every term by -1. So I have f of x minus 1 equals the opposite of x minus 3 squared. So then I add 1 to both sides. F of x equals the opposite of x minus 3 squared plus 1. Oh, sorry, that was a plus 1. So then it becomes a minus 1 there at the end. No, we're good. Sorry. So there is our function. So the vertex is at -3, 1. The axis of symmetry is at x equals 3. And now let's graph. So we know our anchor points. Now there's a reflection along that x-axis because of the negative. So now we're down here by multiplying all of those y's by -1. And now we're going to shift to the right 3 and up 1. And here is our graph. So let's find those intercepts. The x-intercept. So 0 equals the opposite of x minus 3 squared plus 1. So we subtract 1 from both sides. -1 equals the opposite of x minus 3 squared. Divide both sides by -1. 1 equals the quantity of x minus 3 squared. Take the square root of both sides, so we get plus or minus 1 equals x minus 3. Add 3 to both sides, so x equals 3 plus or minus 1. So x equals, so 3 plus 1 is 4. 3 minus 1 is 2. So our x-intercepts, 4, 0, 2, 0, and that matches up to our graph. And then our y-intercept, y equals the opposite of 0 minus 3 squared plus 1. -3 squared is 9, times -1 is -9, plus 1, so y equals -8. So our y-intercept is at 0, -8. And you can see that from the graph as well. But don't forget, you can always solve them algebraically. That's it for this part. In the next part, we're going to be talking about some word problems and some other things. Thank you.